you to think about, so like this is the math problem that we're going to do on the next slide, but I took out all the math bits. Like the textbook always gives you all the things you need, right? But if you're solving a problem in the real world, like you don't have all those things just like plopped right in front of you. You got to think about it. And what do I want? And you got to go find it and all that stuff. So what I want you to do is read through this once, read through it twice, okay? And as you're reading through it, think about what would you like to know so that you could solve the system. So this should be like on your own, quietly in your head. You'll discuss in a moment. But read through it a few times and be thinking about what are the things you need to know to be able to answer the question that's being asked. So I'll give you some time. Okay, now come together with your pods, your groups, and just share out. Like, what are the things you want to know? Tell your pods what kinds of questions you have. Okay, so give me one thing that your group talked about. What's something you would like to know that I didn't tell you? Rocio, what's something your group said? What are the minimum requirements? Yeah. It's hard to meet or exceed minimum requirements when you don't know what they are, right? That would be true like if I never told you about a grading system. You never knew how you were getting graded. So we'd like to know what the minimum requirements, what it's been found out that pet owners want for their pets, right? So that they'll come to our store and buy our pet food. Amy, what did your group say?
How many nutrients are in each bag?
How many nutrients are in each bag? Yeah, so we got to know what are the minimum requirements and then what are the number of nutrients in the bag so that we can make sure that we meet those minimum requirements, right? If you were doing this in a real world scenario, you would have to do that kind of research on your own, right? Look it up online or go to the store and figure out what the bags were and what kinds of things they offered. Is there anything else you want to know? What were you going to say? Oh, okay. Anything else that you're dying to know? Okay.
How different are the two mixes going to be?
And what do you mean by that?
Because it's two brands of dog food, so how different are they going to be? How does that play into meeting the requirements?
Okay, yeah. So, how different are the bags? Maybe we could like specify this second question. How many nutrients in each bag of each brand, right? Maybe one brand is heavy on a particular nutrient that another one is not. Okay, so we could talk about it like that. Okay. Another thing, that's a great question. Like, there's going to be a difference between the two brands, right? And leading into tomorrow, which is going to be linear programming. So linear programming is going to be what we do today plus some more stuff. Okay? And the idea for linear programming is if you can find like what are acceptable solutions, then you can find the solution that minimizes or maximizes something. Usually in our linear programming problems, those are going to be costs and profits, right? We want to maximize our profits. We want to minimize our costs in the real world. So like Logan's question about like how different are the brands, that could come into play tomorrow in terms of cost as well as nutrients, because I want to mix the bags and make the appropriate mixture so like pet owners are satisfied with my mix, but I also want to do it at the cheapest cost to me so I can make the most money. All right, anything else? Okay, so the next slide is going to show the actual book, like or the actual example from the textbook, and they're going to be more like what you're going to see on your homework tonight and what we're going to see in linear programming tomorrow, which oftentimes is just really overwhelming because it's got all the things that you need to know in it. Like the math textbook tells you what the minimum requirements and how many nutrients are in each bag, so that you have the information that you need to solve. But you need to be thinking about like the bigger picture when you first read a problem like that, so that you can try to make sense of it and write a system of inequalities. So this is the actual question that I kind of like paraphrased right here. This is what it looks like. Just looking at it, it's like, whoa, right? So I don't want you to write this down because that would be time consuming. And this is actually on page 514. So whoever has the textbook under their desk, pull that out. We're going to need it anyway when we get to our homework time, so we'll have it out and ready to go. This is on page 514. It's the checkpoint question. Okay. So if you want to write that in your notes, just so like if you want to go back and look at this a different day when you're studying or something, you know where this problem came from. But I don't want you to write this out like sentence for sentence. What I do want you to do now is read the math version of that question and try to like organize the important information for you that you're going to be using to solve. So I answered all your questions. Now you kind of gather that data that you asked for. Okay, so I'll give you a moment to do that. Read and write down important stuff. And you can read it from the textbook if you share. Or you can read it from the board. The problem and you're kind of picking out the important information. You can either read it from the checkpoint or it's also on the board. And you got to gather that data, put it in your notes. You don't have to like solve it right now. You just need to get the important information. Okay, there's no right or wrong way to just like write down the things that are going to be important to you. So this was, I think I first saw Rocio doing this. I saw Austin and Gibbs doing something like this, and I kind of like this because it's like a chart, like a table. I've got rows and columns. So my rows represent my brand X, brand Y, and minimum requirement. And really my rows are A, B, and C, aren't they? Okay, they also went through and actually labeled those, but I could just have had a label on the side and then labeled appropriately. I also saw some people who wrote, like, I'll do it over here on this sideboard. Some people just wrote brand X. And they said, that has 8A, 1B, and 2C in it, or they wrote out units and things like that. I did see also something like this, 8A plus 1B plus 2C. But I'm going to just say, like, you want to be really careful with that one where you put the pluses in there. Because then you kind of start convincing yourself, like, those are your equations that you need, and they are not. Because they have nothing to do with the minimum requirements. Okay, so if you want to write it like a shorthand, like that's what brand X has, that's fine. But I prefer like more of like a list or a table. I don't want to throw in too many operations because then I start to get confused about what's actually my solution, what's not. So there's not a right or wrong way for you to have gathered that data. You were just reading the problem. Okay, so the other thing that we want to talk about before we kind of get going here is, if you focus down at the bottom of this in the math textbook, they're going to give you some guidance, right? Some direction, something to do. So it says, set up a system of linear inequalities. Okay, so a system has one or like two or more. All right. Inequalities, I'm thinking less than, greater than, or equal to, that kind of stuff. That describes how many bags of each brand should be mixed to meet or exceed the minimum required amounts. Okay. The other thing that's really important for you to do with that last part of a problem is read that to try to decide what your unknowns are, right? I gave that instruction to you last week when we were writing our 3-variable systems. Like, really focus and define your unknowns and your variables because it makes it easier to write everything else. So what are our unknowns in this problem? What do you mean by X and Y, Aiden? What would they represent? The two kinds of food. What are you being asked to find? The number of bags, okay? So like it says, set up a system that describes how many bags of each brand. So what are your unknowns? How many bags of each brand? Okay. So X is going to be the number of bags of brand X. And Y is going to be the number of bags of brand Y. Okay? Now, warning. If you skip that step, that seems like, oh, come on, I knew X and Y, right? I knew those were my unknowns. It is really easy on a problem like this with A's, B's, and C's to think that those are your unknowns and to all of a sudden start writing things with A, B's, and C's. First off, that's trouble for you. Because how do you graph with 3 variables? I have not yet taught you that. Okay. So if you're coming up with systems in 3 variables, you probably have incorrectly defined your variables. Nutrients actually aren't unknown to us. It is unknown to us what those are. Are they fiber? Are they protein? Are they iron? Like, we don't know. But we know how many there are. So they're no longer unknowns. The unknowns are the number of bags. Okay. And then if I want to meet or exceed the minimum requirements, that helps us kind of think about, like, what inequality are we going to be using for those requirements? Greater than's or equal to. All right. So I got to meet or exceed these minimum requirements. That's going to be greater than or equal to 16 for nutrient A, greater than or equal to 5 for nutrient B, and greater than or equal to 20 for nutrient C. I just had to figure out what the other part of that is. So think about your unknowns, the number of bags of brand X and the number of bags of brand Y. Think about the things that you do know over here. Okay. If we want to write an inequality for the minimum requirements for nutrient A, we're going to be focused on the number of nutrient A that come in each bag, right? If I only buy one bag of brand X, how many nutrient A's will I have? 8. But if I buy 2, I'll have 16. Okay. If I only buy one bag of brand Y, I'll have 2. If I buy 2, I'll have 4. If I buy 10, I'll have 20, right? We're just like multiplying by the number of nutrients in each bag. So we could say that the amount of nutrient A is going to be 8 times X for every bag of brand X plus 2 times Y for every bag of brand Y. I'll get that many nutrient A's. Okay. So notice when you kind of use an organizational system like a table, all those numbers are in the same row together. And then my next one would be X plus Y must be greater than or equal to 5. So clearly, like in this one, I know that I have to at some point buy at least 5 bags. Whether it's brand X or brand Y, that could be depending on the other nutrients. But the only way, because they each have one nutrient B, I have to have 5 bags to meet the pet owner's requirements. And then 2X plus 7Y. Okay. These, tomorrow, we're going to call the inequalities constraints. And when we talk about being constrained, means like you can't do everything, like you're stuck. So these are like our real world limitations to the problem. I am limited by what pet owners want for their pets. I have to provide them those nutrients or they're not going to come to my store and buy my stuff and all that food is going to go to waste. Okay. There are some hidden constraints in the real world. If X is the number of bags of brand X and Y is the number of bags of brand Y, what other constraints would I include for X and Y in the real world? They should be positive or 0. Right, you're not going to tell someone you should use -2 bags of brand X. What are they going to do, right? Okay, so you can tell them to use 0 bags of brand X. That would be fine, okay? But we have to say that X is greater than or equal to 0 and Y is greater than or equal to 0. Now, sometimes those constraints are hidden because I might say, like, you have to use at least 2 bags of brand X, then X is greater than or equal to 2, and you don't have to include the X is greater than or equal to 0. It's redundant. So it just depends, but overall, like most of the time, if it doesn't specify X or Y's lowest value, you have to constrain it by 0 and above. Okay. Okay, this one, those two, a lot of times in the linear programming questions, people lose a point because they don't include those. So put a little star next to them. Okay. Well, we're going to graph to see our solution. I'm going to use, these are all lines. I'm going to use my intercept method. This is Miss Rocky. Yes. Sure, is he coming back? Okay. Thank you. Gibbs, you're being requested in guidance. You may or may not be back, so I would take 2 things. That's what they told me. Okay, we're going to graph to find the solution. I'm going to use my intercept method. So, like if I do this one, 8x plus 2y equals 16, intercepts are pretty easy, right? X-intercept is at 2, because 8x equals 16 divided by 8, x is 2. Y-intercept at 8, right? That's my intercept method. Put 0 in for the other variable. Okay, so I'm going to need to scroll up so I can get a nicer graph. Now, because I put those railroad constraints, x greater than 0 and y greater than 0, I can just use the positive first quadrant. And I'm going to put my x-intercept at 2 and my y-intercept at 8. See, I need another one. And draw a line. Now, I would maybe ask myself the question, for that particular line, 8x plus 2y greater than or equal to 16, should I shade below the line, like towards 0, 0, or away from 0, 0? Is 0, 0 a solution? No, 0 is not greater than or equal to 16, so we're really shading like to the right of this line. So I'm kind of like bounded in this region or unbounded over here to the right. All right, graph the next one. What are my x and y intercepts for x plus y equals 5? Don't overthink it. 5 and 5. Okay, so that makes it easy. I'll graph the second one in blue. Okay, so I'm going to go right 5 and up 5. Think again for that particular equation or inequality. Is 0, 0 part of the solution? No. So again, I'm shading over to the right. So now I'm bounded by the y-axis, this top part of the black line, the blue line, and the x-axis. So I'm kind of like bounded over there or stuck over there. Okay, the last one is 2x plus 7y equals 20. I'll go ahead and show my intercepts for that. If I plug 0 in for y, that's pretty easy. My x-intercept is at 10. Okay, so I can go 10 right on the x-axis. Notice on this one, and this is going to happen quite a bit in linear programming, if I put 0 in for x, what's my y-intercept? 20 over 7. Okay, that's fine. Don't worry about that. 20 over 7 is really close to 3. It's just a little bit underneath, right? 21 divided by 7 would be 3. So I'll just put a point right underneath 3. Oh, I should have graphed that in red. I'll graph this one in red. Okay, so it's a different color. Okay, and then connect the dots. Remember, I don't need the other quadrants of the coordinate plane on any of these real world problems because I'm going to be constrained to positive values only. Okay, and then would 0, 0 have been a solution to that? No, so I'm still shading above that line. So now think about where your full shading is. I'll shade in green. I'm trapped by the horizontal and the vertical axis, so I don't want to go past that. And then I'm above the red, above the blue, above the black over here. Okay, so I'm going to go ahead and do some shading. But I'm staying above the x-axis, and I would be staying to the right of the y-axis because I'm constrained by x and y greater than 0. Okay, so what that means is all that stuff in green and all those points on those lines that are bordering that, they work, right? Like if I pick a point right here, let's say this is 5, 5 or something like that. If I buy 5 bags of brand X and 5 bags of brand Y, I'll have all the nutrients I need, plus more, right? So can you imagine like this whole region is unbounded? Okay. When it's unbounded like that, it means there's like no maximum. I could just keep buying more and more bags and have more and more nutrients. What we're going to be interested in tomorrow is that question like that I kind of addressed when Logan talked about how different the bags are. Of course we can pick all these different things, but don't we want to buy the least amount of bags for the best deal to make the most money? So what we're going to find out tomorrow is those points, like where you would minimize or maximize something, they're going to happen at the vertices of your shaded region. So tonight on your homework, besides writing the constraints, graphing the constraints, you need to find the vertices. Okay, vertices are points of intersection around your shaded region. So that y-intercept is a point of intersection for x greater than or equal to 0 and the black line that I graphed. V sub 1, we already know that one is 0, 8, right? That was a point we graphed. We have a vertex right here with the black and the blue line. Looks like, I'll call it V sub 2. Looks like V sub 2 is where? 1, 4. Okay, now remember from previously, you can't just say that. You have to make sure that's right. So that's the black and the blue, which were the first and the second. Plug in 1, 4 for x and y and make sure it makes both sides equal. So 8 times 1 plus 2 times 4, does that equal 16? Yep, that's a point on the line. 1 plus 4 equal 5? Yep, that's a point on the line. So 1, 4 was on the black line and 1, 4 was on the blue line. That's actually the point of intersection. Okay. Let's see. We have a vertex right here. We'll call this one V sub 3. Does anybody want to take a guess at V sub 3? Looks like, ooh, on my graph it looks like 4, 2, right? Does it look like 4, 2 on yours? Yeah, it's actually 3, 2. Okay, so on my graph, if I chose 4, 2, that's the blue and the red line. That's these two. If I put 4 plus 2 into this second equation, does that equal 5? No, 4 plus 2 is 6. So that's not actually a point on the blue line. So I would either have to retry a number or then I could start solving the system. So I'm going to show that at the end. Okay, but if I put 3 plus 2 in, that works. And if I do 2 times 3 plus 7 times 2, that works for 20. Okay, so that is the point. And then the last vertex is this one over here, okay, V sub 4, which we definitely already know that one because that's an intercept, that's 10, 0. Okay, there is a point of intersection right here, right? But that's not around your shaded region, so it's not a vertex. Like, this point works for nutrient C, the red line, and nutrient A, the black line, but buying 2 bags and like maybe, I don't know what that value is, less than 3, doesn't meet the requirement for nutrient B. So this is not a solution. Okay, you only want the ones that are on the edges of the shaded region. Okay. Just really quickly, in case you're ever stuck, and this might help with quiz corrections today. Let's say I was having trouble with my V sub 3 because my graph was off. Take the 2 lines that are intersecting. The blue one was the x plus y greater than or equal to 5. Just treat it like a line equals 5. And then 2x plus 7y equals 20. And solve the system. So if I were solving that system, I would multiply this first equation. I would use elimination. I would multiply by negative 2. I would get negative 2x minus 2y equals negative 10. 2x plus 7y equals 20. That is 5y equals 10, so y equals 2. Plug it back in, x must be 3, and I get the point 3, 2. So if it's ever like not at a nice point or you just can't figure out what the correct ordered pair should have been, which is going to happen because our graphs are just going to be rough sketches, then you need to just solve the system. Does anybody have any questions about that? Okay. What we'll find out tomorrow is, like if I tell you the prices of brand X and brand Y, like one might be a premium dog food and one's like a generic dog food or something like that. If I tell you the prices, we can figure out how much these combinations cost because these will work for like the minimum number of bags that we need to buy to meet our requirements. And when we put it into our price function, we'll be able to tell which one gives us the lowest cost, and then that will minimize the cost for us. Okay, so that will be tomorrow. All right, so think about on your homework. you should have constraints, you should have a graph, and you should have vertices. Here is number 65. You have 4 problems. You have the textbook out of your pods. Share your textbook. Take a picture of 65 if you want it on your phone right in front of you as you're working. Everybody should be working on 65. You have over 15 minutes. You can probably get 65 done. Okay. Don't overlook that part about deciding what your unknowns are and your defining your variables. That will be very helpful. I'll check in with you in a little bit.